Switches on, Hello, everybody, and welcome to class this week. I should say welcome to the final live stream class. I just want to take a second and, thank you all once again for bearing with me this semester and indulging me in this experiment. Personally, I think it's gone fairly well. I hope you all have found it the same. I've really enjoyed doing these live streams and giving you all the opportunity to interact when you're available. So I hope you all have been able to get something out of it and have found value in it. It's really it's been a good thing, I think. So I feel like it's something that I'm probably going to continue doing with my online classes. So this week, in our final live stream, we're going to look at the concept of availability and availability in relation to virtualization. Hi, Jorge. Good to see you this afternoon. So this week we are talking about the concept of availability and availability in terms of virtualization. And so we've got our stream objectives up here today. We're going to examine the need for increased availability in today's information-driven world. We're going to understand the availability options and strategies in a virtual environment. And we're going to examine availability in a single virtual machine, in a single virtualization host, and across multiple virtualization hosts. So those are going to be our goals for today for this live stream. But really, before we get kind of too deep into it, let's talk just a little bit about kind of history and how history's led us to this point in time. When we really look at it, history kind of has a bunch of examples of new technologies that become vital to our everyday existence. We need these different technologies to survive, if you will. When you think about the first power plant back in 1882 built by Thomas Edison. When you think about that first power plant in 1882, the first of its kind, providing power, and that's all well and good, but it would take another 70 years to be able to provide electricity to almost everyone in the United States. And then we look at other things like refrigeration, appliances, heating, and lighting. They all fail when the power is turned off. And these power companies, they have, they've employed sophisticated grids, and they've even got more advanced in recent years with the introduction of the smart grid to try to prevent the power from failing. But, at least with some regularity, we're inconvenienced by lack of power. And so we think about this in terms of availability and things that are made available to us. That's one of the earliest things that we have that we needed to be made available in sort of a 24/7 sort of mindset there. And then, think about telephone service along a similar line. The telephone came around mid-1800s. We got the invention of the telephone, but it was brought to market 20 years later. So in the 1870s, you could go out to the store and buy a telephone. even still, it took us another 40 years for us to get a proliferation of telephones in society. By the early 1900s, by 1910, we saw 6 million telephones on the AT&T system. And then 50 years later, we would jump to 80 million telephones. So what this goes to show is not only a need for availability, but the exponential growth that we've talked about in the past. We've talked about Moore's Law and technology becoming, half price and twice as fast. And when we look at the proliferation of technology, we can see it happening the same way. When we go back in time and we look at things like when we look at ARPANET, consider ARPANET back in the 70s. We started with 4 universities on ARPANET, and then as the network expanded, the first time they added a node to the network, they added a contractor on the East Coast roughly 5 years later. And then by the end of ARPANET, they were bringing on board new nodes, one every 20 days or so. So, when we think about the need for availability and the importance of these things in our lives and to businesses, especially, you think about things being mission critical. Power is something that is mission critical. Telecommunications is something that is mission critical. And now network and internet is something that is mission critical. So how can we bring that into talking about virtualization? Well, I'm going to start it off by talking about a concept that you've probably heard about before. And we're going to frame it in a slightly different way. And we're going to talk about the 9s. So in some of your networking classes, you've probably talked about the 9s. The 9s of availability. And we've got the 9s here. The basic 9s. 2 9s, 3 9s, 4 9s, and 5 9s. And, in a standard data, in your standard data center, most of the time, what your goal is going to be roughly 5 9s, right? Like in when you're looking at like the Google Cloud and AWS, they talk about something crazy that's along the lines of like 11 or 13 9s. But when we're talking about the 9s, we're talking about downtime. Or conversely, uptime, rather. Availability. How much of the year is this system available? So when we have something that's 2 9s, it's available 99% of the time. Which, if we put that in perspective of the year, means it can be down up to 1% of the year, or 3.65 days. 3 9s is 99.9% availability, which means it can be down 0.1% of the time, which is roughly 8.8 hours. 4 9s, 99.99% availability, can be down for roughly 53 minutes. Now, our big goal in data centers and, what the ideal here is our 5 9s. So that's availability at 99.999% of the time, which means we can have downtime of 0.001% of the time, which means that, our systems can be down for 5.3 minutes a year, if we put that in perspective with a year, which isn't a long time. Not a long time at all. And this downtime that's in our availability is both planned and unplanned downtime. So we're talking about both the downtime that you need for maintenance, that you have to make sure you utilize, and the unplanned downtime that you can't choose. Things that happen when things go wrong. And when things go wrong, and oftentimes when we're talking about things going wrong, we're talking about, in these sorts of situations, we're talking about natural disasters, things going severely wrong, because the majority of data centers that are, serving contracts that have a 5 nines availability clause in them, they have the levels of redundancy, they have various fail-safes, they have, distributed protocols in place to where everything's covered. So this unplanned downtime typically happens as a result of something catastrophic. But don't forget that we're also talking about the planned downtime here. The downtime that you'd normally go down just to do a little bit of maintenance. Well, one of the important things to remember here is that when things go down, yes, these greater degrees of availability require significant costs. Because in order to attain these greater degrees of availability, you have to have those levels of redundancy. You have to have, big RAID arrays and failover power supplies and backup generators and all sorts of things in place to make sure that these things happen. So it does require significant cost to attain this availability. However, if you promise that availability and you don't deliver on that availability, then you're seeing a significant loss. Oftentimes with these nines contracts, we see, clauses built in where it dictates that, if the individual does not meet, or if the company does not meet the availability that they promise, then they're paying penalties, and that's less than ideal. So paying the money up front is better than paying the money when you fail to provide your service. So we want to keep these nines of uptime in mind as we go through talking about how virtualization relates to availability, or vice versa, how availability relates to virtualization. So we have some traditional solutions for ensuring availability with our virtualized machines. One is RAID, redundant array of independent disks. With that, we are improving our storage availability and performance. Storage multipathing. So what this does is it provides multiple paths for storage traffic. And so multipathing is accomplished by having more than one path from the host to the storage array. So this works really well in virtualization because we can utilize that hypervisor that we've talked about, kind of acting as the conductor in the middle. They're kind of directing the traffic all around to aid us in this multipathing. So what we end up with is actually the physical path is duplicated through the environment between two controllers in the storage array. So what we end up seeing, is that we can route them through separate network switches. We can route them through two physical NICs on the system, on the host server or host device if we need to. So that way, if any of the components fail, a path still remains for the operating system on the virtual machine to use. And this capability is, it's sort of transparent to the operating system and any applications that depend on it, right? And this can also give us some load balancing capabilities. So it's not just a fail-safe, but we can also use it to do some load balancing and balance the data across both paths. We can also utilize NIC teaming. And in NIC teaming, what we're seeing is multiple network cards linked together for more bandwidth and alternate paths in the event of a NIC failure. Essentially, we have these bundles of NICs, physical NICs, in a host. So this is typically going to be on a server that you're going to see this. This group can, it can load balance traffic across the physical devices for higher throughput, or as it says here, if one of the NICs fails, it can spread out the work between the remaining NICs. And then all of the physical NICs can work with the same virtual switch. So we see this working well with the virtual environment because we can utilize all of these physical NICs and route them through this virtual switch to make things sort of easy on ourselves. And then there are clustering solutions like Microsoft Cluster Services or Oracle RAC. And we can implement those in VMs just like we would implement them on physical servers. And we could implement them as a combination of virtual machines and physical servers. So if we need clustering solutions, we can utilize these services just like we would on a physical server, on VMs, or in a grouping of both VMs and physical machines. So that's a good way to utilize that for some fail-safe purposes. Let me go back to that just a second, because here it is in my notes. My notes are a little disheveled today. So essentially, what we're doing is when we're clustering, is we're linking together two or more servers with a physical network and shared storage resources, and the clustering software, which is the Microsoft Cluster Services or the Oracle RAC. And then a simple cluster allows an application to quickly recover from a server outage. So when the primary server fails for whatever reason, the cluster software routes the application traffic to the secondary server. So essentially what we're doing here is we're more or less making a... it's almost like having a raid of servers. I guess might be a good way to put it. You know, if one fails, the software immediately routes it to this other server, and you don't see any loss of connectivity or any downtime. So we'll just add a little bit more on to that. So let's talk a little bit about virtual machine availability. Virtual machines have enhanced high availability. So virtual solutions have a degree of high availability already architected into them to some degree. So with your virtual machine tools, as we see here, I was trying to find it in my notes, but really the slide is just as good as my notes here. With the virtual machine tools, we can automatically reboot a failed or frozen virtual machine without any intervention. It's going to identify the fact that the machine has crashed or the machine has frozen, and the virtual machine tools operating in the hypervisor layer can go ahead and take and reboot without anybody else having to get in the way and manually initiate it. So we can take these enhanced high availability tools to be able to utilize this. We also have application high availability, and these are tools that can restart a failed application, even though the operating system is still running. And we can utilize those within the system. Storage and network I/O, QoS features that ensure critical application workloads receive adequate bandwidth in times of contention to prevent application interruptions. So, what we're dealing with there can actually be proactive. You can think about it in terms of, We've talked about I/O contention before, with different virtual machines needing resources and kind of them butting heads and colliding into one another. With the storage and network I/O features here, we can ensure that critical application workloads are getting the bandwidth that it needs, so that all the important stuff gets what it needs, and all the lesser important stuff's kind of put in a queue, kind of shuffled off to the side, and not worried about. So it's proactively resolving performance problems due to I/O contention here. And then all the other best practices really still apply. Properly securing your servers and making sure that antivirus protections are put into place. So we're talking firewalls and all of the necessary precautions to make sure that everything is up and running to prevent bad actors from getting into the system and taking down your machines that way. Now, here's our example of clustering, and we talked about clustering just a little bit a few minutes ago. So clustering is two or more physical servers linked together via network and shared storage resources, and we said that when one server fails, all the VMs on that server are automatically rebooted somewhere else in the cluster. So we can talk about that a little more now. So the two... Let's see, is this the right? No. This is. So when a virtualization host fails, all of the virtual machines dependent on it also fail. Because of shared storage, high availability has access to the virtual machine files and can restart all of the failed virtual machines on other hosts in the cluster. And a few minutes later, they are all running again. And then, we have performance algorithms that are in place that ensure that there's enough spare capacity on the hosts before adding these virtual machines. So when you're planning for configuration of a virtual environment, what you want to do is you want to consider spare capacity for high availability. Because that's going to be one of the constraints of the environment. Needing to have some additional space for or needing to have some additional performance for these sorts of situations when one server needs to, or one host needs to take over for another. In our virtual environment, this functionality is really designed into the architecture, and it protects all the virtual machines on the host and application workloads that couldn't be protected because of the constraints can partake of increased availability just by the virtue of being on virtual infrastructure. So at the end of the day, though, in this sort of situation, a failed host server still means crashed virtual machines. It's always going to mean crashed virtual machines. In this case, you just have a failover. You have kind of a failsafe in place. However, there is an exception to that. And that's fault tolerance. So, we talked about clustering software. Similar to clustering software, but really providing a greater availability, is fault tolerance. A fault-tolerant virtual machine is able to withstand the failure of a virtualization host without incurring any downtime or impact on the server or user application whatsoever. So we see in our graphic here a sort of simplified illustration of a fault-tolerant virtual machine. So when fault tolerance is enabled, a second virtual machine is instantiated on a different host than the primary. So we've got two different hosts here at play. And it rapidly duplicates the state of that primary onto the secondary. And they're sort of lockstep. As one changes, the other changes. And the two virtual machines sort of monitor each other's heartbeat. And in the event of the primary host's failure, the secondary immediately takes over as the primary. And then a new secondary is created on a different host. And then the virtual machine is protected again. No transactions are lost, and users are not impacted at all. Now, this requires a lot of additional network resources. But what it doesn't require is specialized software. The capability to do this is built right into the hypervisor and enabled with the little checkbox selection. Now, ideally, because of all of the extra resource consumption, we're essentially, doing a 2N redundancy here. Only mission critical workloads are really selected to be fault tolerant. So because of the use of all the resources here, we kind of want to limit what we do this with. Live migration is essentially where a virtual machine can be moved from one virtualization host to another without downtime or impacting an application's performance. If a physical server fails, it's too late to move the virtual machines. So where this does impact availability is during planned downtime. In a physical environment, when a server needs maintenance or even replaced, the application needs to go offline until the maintenance or the upgrade is complete. The exception to this would be a system protected by a cluster solution, where the application could be failed over to a secondary server. In the virtual environment, when the server needs to go offline, all the virtual machines are migrated to hosts in the other cluster. Or rather, all the virtual machines are migrated to other hosts in the cluster, rather. So in our graphic here, this sort of illustrates the process. We have the server in the center there being put on downtime for maintenance, and the migration going out to the other two hosts. So what we end up seeing is no application downtime is needed and no users are impacted. So hosts can be transparently replaced in the cluster, and maintenance work done, and it doesn't impact individual virtual machines. So we can schedule downtime for a long time on this one individual server, like we have here in our example, and we just take and migrate the critical components to other hosts during the maintenance. But remember, if that server were to fail, it would be too late. You can't migrate after a failure. We can do a similar thing with storage and storage migration. We can also use this to alleviate disk contention without interrupting a guest, move data to newer storage. And this can be used to automate and resolve storage issues. Protecting data centers. We have replication. So replication solutions can provide current copies of a production site ready to be powered on. So this is still really a method of recovery. Essentially, what we're doing is we're replicating hosts from one location to another location. And what virtualization does is virtualization makes this really, really easy. So oftentimes, this sort of replication type solution is utilized in accordance with like disaster recovery and disaster recovery planning. Because we get a standard infrastructure that we can utilize as a basis for transferring hosts from one site to another. And ideally, in the future, as our last point here makes, not only would this be good for recovery, but it would also be good for movement, where we could just take and move things in a live manner and just have everything migrate and be up and running in a different location quickly and easily. And that's that. So, bringing me to my Stream 12 summary, and we went a bit over. So I kind of rushed it at the end there because we did go a bit over our time that I normally like to spend. Today's service expectations have made high availability a crucial part of server implementations. Traditional availability solutions and strategies can be deployed in a virtual environment. New features and solutions can provide better overall uptime at a lower cost in a virtual environment than a physical environment, and availability capabilities cover single virtual machines, single virtualization hosts, a cluster of hosts, entire data centers, what have you, to deliver the level of service new cloud applications are demanding. So that's all I have for you. Thank you. That was the last live stream. I'll turn the music back on for just a moment. Thank you for coming for the entire semester. And best of luck to you all.
What am I?